Good morning, good afternoon, good evening. This is Mr. Payne bringing you linear regressions on the calculator, Unit 10, Lesson 7. Objective for today. You will be able to input your bivariate data into the calculator and create a scatter plot on the calculator. You will then be able to write an equation with the data given to you for the line of best fit. This is review from yesterday. A lot of the wording and vocabulary is the same. What you're learning how to do is how to use your calculator to find this information. In the last lesson, we drew lines of best fit by hand so that we could model bivariate data that had been graphed on a scatter plot. In this new lesson, we will see how to use your calculators to find the equation of a line of best fit. This is often referred to as linear regression. We will work in the first exercise with the data set from the last lesson. Exercise number 1. A survey was taken of 10 low and high temperatures in Fahrenheit in the month of April to try to establish a relationship between today's low and temperature and high temperatures. Enter data into lists on your calculator and create a scatter plot using your graphing technology. Size the window appropriately so that the data takes up a majority of the screen. Compare this to the scatter plot you created in the last lesson. So the very first thing we need to do is create a scatter plot using a graphing technology in our calculator. So the first thing I want to do is insert my X into list 1 and insert Y into list 2. Remembering how we got there, we use the stat button and then type our information in. Second thing I'm going to do is hit second Y, and then this screen is going to come up. So second Y, we want to talk about my stat plots. I'm going to hit enter. Then I want to turn on my scatter plot. At the original, it's going to be in the off position. You want to arrow over and hit enter. So I want to turn it on. Then I want to choose scatter plot. As you can see right here, there's a line graph, there's a histogram, and there's box and whiskers. I want to make sure that the first one is identified. Then I want to make sure that my X list is L1 and my Y list is L2, just like I said here in my directions. And then go ahead and hit enter. Choose any appropriate window. Before I can go ahead and graph, I want to make sure that I use the right window. So the first thing we're going to do is hit window. Then we're going to take a look at what my X's are. My X min is 26 and my X max is 45. So what I'm going to choose for my min and my max is I'm going to say my min is going to be 20 and my max is going to be 50. And you can see that right here I already made my adjustments. Then I'm going to go ahead and I'm going to look for my Y mins and my Y max. My Y min is going to be 45 and my Y max is going to be 75. If you look right here and right here, I've already made my adjustments. The last thing I would like you to do is make sure you go to Y equals and make sure there's no other graphs drawn in there or written in. So it should say nothing for where Y equals. And then I'm going to have you hit graph. As I hit graph, this should be drawn for you. As you can tell, this is a scatter plot. And I can draw my line of best fit right inside my scatter plot. Part B. Use your calculator to find the equation for the line of best fit. Round the slope of the line to the nearest hundredth and the y-intercept of the nearest integer. Compare this to the slope you found in the last lesson. I would like you to write these calculator strokes down. Stat, calc, this one's new. For this time, stat, calc, you know how to do that. Then hit 4. 4 is my linear regression. Then hit enter, enter. Remember, equation of a line is y equals mx plus b. In this case, instead of using m, they use a. So y equals, and it says round my slope to the nearest hundredth, 1.16 x plus my b is 19, because they say round that to the nearest integer. So my answer is y equals 1.16x plus 19. Then it says, let's look back to our slope from lesson number 6 that we learned in our video. And I don't want you to look back, but I'm going to tell you that my slope when I found it before is 1.6, or 5/3. How close are we? My line of best fit was a little off that day before. That's just something to take note in and to see how this is more accurate. C. Explain what the y-intercept of this model represents in terms of the low and high temperatures that are being modeled in this problem. My y-intercept in this case was 19. So what does that mean? When your low is 0, because that's your x, don't forget, your high will be 19, because that's my y. That's my y-intercept. So if I was looking at my table, my 0 would be my low, my 19 would be my high. D. How would you interpret the slope of this model in terms of how low and high temperatures change with respect to each other? Well, my slope is 1.16, which means that over 1, which means that my change in y over my change in x, every time my y goes up 1.6, my x will go up only 1 degree. So your slope grows gradually. For every 1 degree Fahrenheit increase in the low temperature, the high temperature increases by 1.16. My question to you is, will my low ever catch my high? The answer to that question should be no, because my height or my high temperatures increase more rapidly. My high temperature, which is my y, increases faster than my low temperatures. I want you to have a great Monday night. Have your WSQ written. The words that I want you to remember for tonight are linear regression. And remember and have written down all those calculator strokes on your notes for me, please. I have them written down, and we will go over it again in class so that you can actually type them in, but I want you to have them written down. Have a great night.